Hi everyone, my name is Sylvia. I'm the Marketing Director at Tom Sawyer Software. Welcome to the second part of our webinar. If you missed the first part, feel free to go to the Tom Sawyer Software YouTube channel to watch it. For this second segment, Josh is going to teach you how to use Tom Sawyer Perspectives to customize your application's user interface and turn a single data set into multiple linked topologies and data views. For those of you who are newly joining us, heading today's webinar is Joshua Feingold, Solutions Engineering Manager of Tom Sawyer Software. Josh leads the solutions engineering team and oversees pre-sales engineering as well as prospect and customer technical support. He's also involved in planning and working on professional service efforts and regularly travels to visit customers and attend events to demonstrate the company's graph visualization and analysis solutions. So without further ado, I will hand it over to Josh, who will now begin today's presentation.
Thanks, Sylvia. So I just want to start out. We mentioned that there is a part one of this. Tom Sawyer Software's YouTube channel looks like this right now. This is our latest video. It's called Tom Sawyer Perspectives in Neo4j to build applications with graph capabilities, part one. Part two is being recorded as we speak. And obviously, these will both be available for your future reference if you ever need them. So yeah, this is just our YouTube channel. You can see we got a nice little banner here. So if you need that in the future. We're going to start by doing a little recap of where we are. So we're using a Neo4j dataset. It's the Hubway dataset. It contains things like bikes and trips with starts and ends in them. That connect stations to trips, and so we've got a topology that is based around people taking trips on bikes from one station to another, and so those are the members of our graph here. So we have this shiny new project, which you'll get to see in a minute, but we will loop back and see where we finished off last time. So last time we had a very static topology in front of us, and we ran an integrator. We see a data set come up, and we had some little circles that represented trips, some triangles that represented bikes. We had some nodes that represented people, nodes that represented stations, and we had the supplementary station-to-station view. All right, so this was useful, but perhaps doesn't give you all the features that you might want. So we're going to talk about how to turn this application into something that's a little more interactive, a little nicer to look at, and really kind of dive down into the details today of what the steps are that go into that upgrade process. All right, so now let's go ahead and jump back to the full version of this project. So again, we're going to do a preview. And we're going to start out with a slightly different set of data. It's just going to be this one individual here. But you can see that we have dressed up this UI a bit. So this is a female. So she has a nice icon with shiny hair. And we can load her neighbors. So now we're interactively exploring the data. And we can see all of the trips that we've loaded down here. We can load the neighbors of this trip to find out what the bike was. So we've added this this little heart icon because this is a set about bikes, and we love bikes. So we're just going to put a little heart here. We now know that this bike is shared between these two trips. We know that this station is the start and end station for this this trip here. Right, because we've got the green line showing the start and the red line showing the end. And we have these stations with more advanced labels, with tooltips, and with kind of more of what you want to see. And you can also see that we've loaded a bunch of trips about which we do not know very much right now, right? So we have all this data loaded, and if we select them, we can see the member name associated with them, the start date, the end date, and the station names, but those stations haven't been loaded yet. So we can hop over to our station-to-station view, and we can see that we've also added some additional UI elements that not only represent stations that we know about, right? So we have all the details about this Stewart Street at St. Charles Street, and we can have a nice tooltip that displays that. But we also know from our trip data that there is this station down here called Kenmore Square / Com Avenue, about which we have not loaded any of the data, right? So we've taken this this basic template and we made it comprehensible, and we've made it into this supplementary usable bit of data. So now we're going to take a step back. So we've kind of added all this stuff. Oh, and actually, if we're interested, so here's this Boston Medical Center. You just jump in here to the search text. So we explored, but we can also search. So we'll just hit Boston Medical over here. Search the database. Ran a query, and now we've got all our details on Boston Medical Center. Right, and so now when we mouse over this, we can see all the details that are associated with it, and it's changed the layout somewhat because now we've gone from a naive placement of where Boston Medical Center is to actually knowing now that Boston Medical Center is east of Washington Street and Rutland Street, and west of Stewart Street and Charles Street, and south of both of those. Right, so now we're actually using the detailed descriptors of this location to inform our drawing. So I'm going to go ahead and close this down, and we're going to start digging into how I accomplish some of this stuff. So you'll remember last time that we had a Neo search. Here we've simplified the search because instead of loading a topology around an area, we just have a search. So we're just going to look for members who are of the type member, where member name is within our search. And if you remember last time, we talked about this parameter. So this is a string parameter, which is a concatenation of this ignore case, wildcard, search text wildcard. And the search text is literally just what we're typing into the tree. So we've got a search very similar to this for members, for stations, and for bikes. We're not enabling search on trips because trips have no properties. They only have an ID. Searching on a particular trip ID is not something that a human user would typically do. You're going to search on a member or a station or a bike and find out information about any of those things, right? So all of these are derived. The only information that's coming directly from the database is the trip ID that's embedded on the trip itself. Right, so that's how search works. The details view loads the neighbors. Right? And so to accomplish this, we have, again, we've written Cypher queries. So we're going to match a member who has gone on a trip that is a trip. And since this is the details of a trip, we're loading the neighbors of a trip. We're checking that the trip ID is within our search parameter. And here we have a very different search parameter. So we saw that you can search on, that you can add a parameter that's a string, but in fact this is more flexible than that. So search here is equal to the selected trip. And a selected trip, if we jump back to our schema, is a new model attribute that is a list of integers, which are the IDs that are currently selected in the trip. So if we look here, you can actually see that there is this interconnectivity between any type of data you can put in your model and any type of object you want to search on. And we're just going to, we duplicate that same methodology where we're looking at the ID within our search for trips. We know that the only adjacent element to a member will be a trip, so we only search in trips, right? So if the member name is within the search, and here we're using the selected member attribute. Right, so we've updated our integrators to reflect the fact that we're going to use a data exploration approach instead of a static data loading approach. We've updated our templates so that now our image is coming from a file that we are defining based on the gender parameter. Right, so we've changed to an image, and we're looking in the resources images member, and then if it's gender female, we're going to use the female image. Otherwise, we're going to use the male image. Right, and these are all just default templates. All I'm doing here is using a parameter to set the value of the image. In the text, we're going to show the name. In a tooltip, here we've defined this tooltip to be dependent upon name, gender, birth year, which we're defining by born in and the zip code. All of these are data driven, right? So you can do that same thing for bikes. Bikes are going to be simple. Stations, which are going to be very similar to members, except they've got different data elements. And trips. Trips are going to remain simple, just because it's just a trip. It's there to show connectivity within the data. It is not itself an element that is densely packed with information. All right, and now we have fake station. So fake station is pretty interesting. Fake station shows that we have inheritance. So we have this template that exists. It's called station. And for a fake station, which is one that we are generating from the connectivity data of the trips, we want to inherit almost all the properties from our parent station. One thing that we want to change by default is the name, because it's not going to be associated directly with a real element. The name is going to have to be handled somewhat differently. Same with the tooltip. We don't have any data about it, so we want to change the tooltip to be unspecified. These green arrows show that we're inheriting values, and we can actually filter them out to just see what we're changing here. We changed the background color instead of being transparent. So in the parent example, the background color is transparent, but just to create that visual difference, we can set this background to look different. So no, and I want it to show up in gray to say, hey, this is something that we don't know about. Size and position are all going to be the same. The expanded UI is going to be the same. Again, these edges were somewhat modified last time, but you can see that we have improved some of these edge definitions. Then we jump into the drawing, and this is where things have changed the most. So inside of these member and station nodes, we are just creating member stations bikes. Inside trips, however, our logic has changed. So last time, we were generating nodes if we had data missing in our main topology. That's no longer desirable because we want to use a data exploration approach. We don't need to create dummy nodes to fill in gaps. We just want to make sure that nodes exist and then connect to them when they do. Because we have this option now of interacting with our data in a much more powerful way, we don't need to kind of make these assumptions about the way things look and the way things should be, because we can actually go find them now interactively. Right, and so we've got a couple filters, and we've also added a search, which is a pretty cool thing. So after I show this search, so now we have these element types, members, stations, bikes, trips, and we can search on them based on values that are specified per element type. So members, stations, bikes, and trips. Right, and we can use our expression language here to format the date of this start date so that it's a little more compact, right? So month, day, year, hour, minute. And then the end date, we're just going to assume that it ends on the same day and only display the hour and the minute. And so let's jump back in and see some of these again so that we don't forget where we're going and why we're doing all this stuff. Right. So here we can see we've got this female 1976. Let's see if we have anyone else from that same birth year and zip code. And we're going to hit the search database, and we're going to use this updated value of the search string. Look at that. We have a male member from that same zip code and birth year. He's now selected. We can load his neighbors. Load her neighbors. And now we can see if we are only interested in people who were born in this year and live in this zip code for some reason, we can see the station-to-station view associated with them. And now we see all these generated stations. Again, as last time, we have this strong visual indicator that this bright green thick line is a trip that has been made many times. So we'll just go ahead and select one of those trips down in our table. Go back to our reference topology. Here we can see that trip. We'll just load the neighbors of that trip to load the bike associated with it, as well as the start station and end stations. You can see the topology has changed a lot. Let's get some other trips with some nice redundancy values here. So here we've got 3 copies of the same trip, so we'll load the stations associated with that. We've got 5 here. Load the stations associated with that. And it is perhaps the case that this is no longer the best way to view this data. This circular layout doesn't seem to be terribly informative right now, so we're going to change the layout views and switch over to hierarchical, or orthogonal, I apologize. You can see now that we have a very tight schematic. That circle was a very large view. Now we have a much narrower view on our data. And I'm just going to do a little more exploring and see how that affects all of our. So you can see we've loaded some more of these station views. And again, this has updated the positions of our nodes about which we have data so that we have a better reflection of the actual geography in here. So these custom actions that I defined that allow me to do things like load neighbors were not available last week, and the reason was because that's more advanced usage of the software, and it requires a little bit of customization. So I'm going to dive in right now to the types of customization that takes and show you that even though it's a custom thing, it's actually a pretty straightforward custom thing. So here's my Eclipse workspace. This is just loading in as the into the class path. I've just included the libraries for Tom Sawyer Perspectives. And you can see that I have this extensions.xml file. Right, so extensions.xml is how we tell Perspectives that we have some custom code that we want to add in. We have this load data action, which gets the details, and we've got the search database action. Here we've just defined them as being in the action package and being the details action item definition and the search action item definition. And that's reflected inside Designer. If I go into my drawing here, we have this hierarchy. We've been working a lot within the definition, but this behavior heading contains toolbars and context menus. So we're just going to go into the default toolbar. And you can see here that we have a definition of all of the stuff that appears when we run a preview, right? So we have this save as image, we have print setup, we have print preview, we have print select. We have a folder now that contains all of our zooms, all of our layouts, and we have this load neighbors custom action, and we have a delete tool that we didn't have last week because we were loading static data. You don't need to clean up the static data that you've loaded, you just usually want to view it. All right, so if we jump into this toolbar, we can see all of this stuff. All right, so here we have a separator. We've created a folder here called layout, which you can see right here. Layout contains all of our actions associated with layout. It has a separator in it. So here we've got our individual layout types separated from global and incremental layouts. And we have this load neighbors action. And so if I want to get rid of this for a moment, let's just go ahead and delete that. And I've got this custom action that I want to load. How would I do something like that? So I've got items. I want to add an item. And so these are all default actions that you get when you're working with a toolbar, right? So we've got activate tool, we've got save as image, we've got all of these things that we've seen. You can do selections, you can do view, expand and collapse, all of the different layout calls, labeling. And then at the very bottom, we have this on-demand actions folder, which is what I called my custom action folder. And inside it, I have an action called load data, which coincidentally is the action, the name that I gave to my action right here in this XML definition. And so now when I want to add an item, it's very easy. I just say, I want to load this data. And the text will be load data. And I'll find an icon. So I prepared one here. So over in my resources images, I've got this details action. This is just a little 16 by 16 icon that I've loaded. Go ahead and open that, assign that. Now it's on the toolbar. So we'll move that back up to its previous position. We've also got a lot of power to define tools. Here we have a delete tool. If I click on this operation, I can select operations that are associated with it. Right, so activate tool. The tool is the delete tool. Here I can go into the definition, and these are all different types of tools that you can define in terms of rules. So here, my delete tool is always going to delete the thing that I've selected, and it's going to delete the model elements associated with it. The rules here can be modified in a lot of ways. So here, because I want it to work the same way for every element, I've got it set to always, but you can change that. You can have it sensitive to the tags. So for example, if I click on a station or a member or a bike, it can work differently. And then the actions, you don't necessarily have to delete the entire model element. Maybe a delete action is really a clear, so you just want to reset some set of attributes. Right? So this tool is very flexible and allows you to do a lot of nice stuff. And maybe it's the case that after you've deleted something, you want to do an incremental layout and kind of clean up your drawing, so you can actually build that right into the tool logic as well. So you can see that we've got a lot of power and flexibility to either add external actions or customize the sorts of default common actions that you would want to do. And this delete tool is very nice because it does a wide variety of cleanup actions, from full deletion to resetting attributes, and it does it all without any custom code. All right, so here you've got this search field item. And the search field item, all I did to create this, so I'll just go delete this again, create it from scratch. So I defined my search down here, as you may remember. I just chose the attributes that I wanted to search on. All right, so very simple to define right here in Designer. And now we can just click on this Add Search Field button. The only search I have defined is search 1, so that's what it's going to use. I can set the background text. I can set the tooltip text. If there are no results, I can choose what it displays. All of these, just kind of sizing issues. Just hit OK, and that's all it takes to enter a search field. You just choose the parameters, hit OK a couple of times, basically. Right, so from here, it's really just a matter of deciding what the behaviors are that you want inside of your application, right? Once you have this sort of power and flexibility, you can accomplish nearly anything you want to do. So let's say that I'm not really interested in this person or this bike, or we'll load the, but we are interested in this bike, right? So we'll load the neighbors of this bike, and so this is the bike that was used for all these trips, right? And maybe we'll even get rid of a whole bunch of these nodes that aren't associated with this bike, or a whole bunch of these trips that aren't associated with this bike. And we'll just see what the station-to-station view looks like here. So these are a bunch of trips that this bike has been on. We know about these stations that it's been to, but there are a lot of stations that it's been to that we don't know anything about. And one of the interesting things that you might be looking for if you are trying to decide things that you want to do is to look at the history of a bike. Maybe you need to know where every bike ends up eventually so that you can do maintenance at a couple central locations. Maybe you want to know if there are individual places where, individual stations where you put a bike where bikes leave more frequently than they enter, right? So here, we have a pretty strong reflexive edge. So this bike goes to and from Washington Street and Rutland Street a lot. So people are making a lot of local trips there. It's going to and from Kenmore Square and Comm Ave. So this is nice because there are 3 unique trips in each direction. So the throughput of bikes there is, we're at a nice equilibrium. And just in general, you can learn things about people. You can learn things about bikes. You can learn things about stations and how stations are connected to other stations. Right, so if we load all the trips that are associated here, you can see how that station, loading all the stations, obviously will bias results toward it, but we can find out, like people really like to go from Washington Street to Rutland, Washington Street and Rutland Street to South Station at 700 Atlantic Avenue. Right, maybe we want to find out, maybe we're interested in 700 Atlantic Avenue now. So we'll search on it, we'll load that up. And we can see that it's actually here, selected over here, selected in the primary view, load the neighbors. All right, so this load neighbors action is obviously very powerful. So I want to go into a little bit more technical detail. We aren't going to spend a ton of time diving through code, but I am going to show you some code here to actually show you how that type of action is accomplished and how it's actually a pretty simple thing to do. So we've got every action has a definition and it has an action item. So here's the definition. So this is my details action item definition. It's got a desktop implementation and a web implementation, and it's a drawing view action item. Here we're just defining the image that will show up inside of Designer when I go to select it. Here we have a new desktop implementation, and all we're doing is saying that it's a TS swing drawing view action item that's associated with this definition. And on action, we're just going to set a wait cursor, and then we're going to call on action in this details action, and then we're going to reset the cursor. And very much in the same way, we have a web version that just calls details on action. So let's look at this details action method. Seems like a pretty important bit. So on action is just composed of getting all of the tags that exist. We've got this Hubway constants that I've defined here, where I've just taken important attribute names and pulled them in as constants so that I can reference them without having to worry about fat fingering a name. And then for each tag, we're just going to update the integrator associated with that tag. So back in Designer, we have this details for the trip, details for a member, details for a bike, and details for a station. So for each trip, we have an associated details integrator. And then if this update integrator returns true, that means that there were model elements inserted as a result of that update. So if anything was inserted, we're just going to go ahead and update the view. And then we're going to call layout if needed. So let's look at what it takes to update integrator. So we're going to set this inserted value to false. We're going to turn off events because we're not interested in all the individual stuff that's going on. And all we're going to do is find the integrator name, find the name of the key attribute for that model element type. So for a person, that's a name. For a station, that's the station ID. For a trip, that's the trip ID, right? So that kind of thing. We're going to pull down the integrator where we just use this integrator name that we derived. We're going to create a list. So for trips and stations, the identifier is an integer. It's a string for members and for bikes. So we're just going to define what type of list is appropriate here. We're just going to get these selected elements, right? So the selected elements are just pulled in by getting the model selection and getting all those selected attributed objects with this tag, right? So all the nodes with the specified tag or edges with a specified tag are going to come back as selected elements. Then we're just going to go through them, store their ID attributes, and use that to set the list, right? So we had this list attribute, right? Selected bike, selected member, selected station, selected trip. Here in the code, we just have a model set attribute call where we're going to take the name of that list and all of the ID values that we pulled out inside our loop, and we're just going to set that on there. And now we're just going to let the integrator do its work, basically, right? So down at the bottom here, we're going to reset the integrator. We're going to set the model to be our current model, and then we're going to update it based on the values that we set inside of this ID list, right? So this is all it takes to update an integrator. Is this integrator reset call, integrator set model, and integrator update. And all of this is basically logic for us to connect the selection inside of the application with the list of selected items that we're using to drive our Cypher query. Right, so very straightforward stuff. And in fact, the search action works exactly the same way. Right, so here it's even simpler because we aren't having to go through the model. We're just making sure that the search text is of a reasonable length so that we're not going to get nonsense results. And then we reset the integrator and update it. And in both these cases, we're just going to make sure, here we're doing it. Here we're doing the check for integrator updates after we do all the individual. We're going to check for layouts after all the individual calls have been made, right, on this updated integrator. And for the search, we only have one integrated update, so we call it immediately. We're just going to create a global layout command, set it to fit in the canvas, and transmit the global layout command. So again, we've found out if we've got stuff. If we do, we want to update the layout of the drawing so that we don't have something that's strange looking after we change the contents of the drawing. So it's actually pretty straightforward stuff, and they're about 150 to 200 lines of code total, including things like getters and setters. For each of these action classes, about 20 constants. And so that's all of the custom code that had to be written to take us to the point where we have a fully interactive application where you can explore your data and find out about what the things are that are important to you. All right, so this is sort of the thrust of using perspectives on the front end, especially when you've got a powerful exploratory search like Neo4j on the back end, right? It just allows you to get at your data in a way that allows a non-technical user, right? So your boss or your boss's boss, who may not know as much about Cypher as you do, to use all of the power that's built into Cypher in a way that's just natural and intuitive, and to link together all of these different views of data to find out what it is that they need to see and that they care about. So I think this is probably a reasonably good time to break for some questions if we have any, Sylvia.
Let me check real quick. There aren't any right now currently, but all attendees, if you see there's a questions panel actually in the control panel for GoToWebinar. If you have any questions at any time, you can feel free to type them in. And also there's a hand raising button if you have a question and we can call on you. So Josh, I'll let you know if there's any questions that trickle in.
Okay, sure. So I want to talk a little bit more about using search, because this is a very powerful thing. So search here has two aspects. there is the aspect of the search against the back end, right, which is going to return objects that are in the database. But then there's search in the front end, which allows you to narrow down your topology and look at, rather large data sets in a much more comprehensible manner. So I'm just going to start making this data a little bigger. Okay, so that's probably a little bigger enough. So now we have a lot of stations over here. Let's pick a station, perhaps Seaport Square. We'll search the database. So now we have Seaport Square. And inside of this view, finding Seaport Square is not going to be as challenging. But if we go back to our reference topology, it's pretty tough. So if I want to explore around Seaport Square, I'm going to have to find it. I type Seaport. We actually have a Seaport Square and a Seaport Hotel. Let's lay those out to be near each other. To be less near each other. So let's hit this orthogonal. You can see that even at a reasonably sized drawing, this orthogonal layout stays quite fast. So here's the Seaport Hotel. It's actually isolated right now. Let's see if we can't link that into our main data set. Load up some trips. Now we can look around. And perhaps we want to see every trip that was taken on 8/16. So now it's not just the names of people and the names of stations that you can search on, because we defined our trip to key off of both the ID of the trip, if you actually know the trip ID for some reason, and this date attribute. We can go through all of these trip starts and ends that happen on 8/16. Maybe we decided at this point we're not interested in bikes anymore, and we're not interested in members. We're mostly interested in stations and trips. So now those are filtered out and go away. We'll just fit this back in. And we'll do a little incremental layout to tighten it up. And now we can see that these are all trips for which we have no station data. So maybe that's an interesting place to start exploring again. So if we go back to our station-to-station view, you can see that our graph is becoming more and more populated, and that our locations are becoming more and more constrained relative to one another, so that we have something that is becoming much more like a real geographical map, or at least a geographically hinted map, that shows where these stations are located physically, one relative to another. So that geographical hinting is something that we actually accomplish without any custom code. That's something that is accomplished right in Designer. So here in this station node, we're going to add a station. But then we're going to create a bunch of layout constraints that will apply to the station and tell it where it needs to live relative to everything else. So we've got a latitude sequence constraint, and we've got a longitude sequence constraint. We've got a band constraint, so that nodes that are on the same latitude and longitude will appear together. And then we're just going to go ahead and add nodes to each of these constraints. So this one is going to add it to the latitude band. This is going to add it to the longitude band. And these are actually adding it to the sequence constraint that we've created up in the model roles. So all of this flexibility and customization where we conditionally depend upon these attributes to define the positions of stations that we've loaded data about. All of that is done without any custom code. All right, so the only thing that I've had to do outside of Designer here is write a couple actions that allow me to run integrators. And I define the integrators themselves within Designer. And I just connected each of these integrators and the actions associated with them through a very straightforward process of using an XML definition to tie the class to an action, and then that action into our toolbars. We can find out about, the most popular trips that go that are surrounding a particular station. You can find out about this member who makes a lot of round trips around Feingold Station. Perhaps it's the case that if I have an app that targets marketing, that this guy who spends a lot of time in this local area will probably be interested in that sort of geographically hinted marketing, even if he's not physically in that area at the moment when he's looking at his phone. Here we can just find all of the connectivity between these stations. So that, at least at high level, is how you accomplish taking a data set that you are viewing in sort of a simple static way, adding onto it a much more customizable front end with things like tooltips and customized images. And in fact, our UIs can get much more complicated than this. But for many purposes, this is a very good first step, especially if you're going to create something that's going to be viewed statically, such as submitted to a Show Me Your Graph competition. That these types of images are very nice. If you're looking for something with a lot of interactivity, you can create that interactivity very easily. You have a lot of power to view your generated topologies in a variety of ways that may be helpful depending on the exact nature of the data that you're viewing. Um, and so I think that Sylvia, unless we have any questions, that's going to wrap up this second part of this webinar.
Yep, great job, Josh. There actually aren't any questions at the moment, but if anybody has any questions at any time, feel free to let us know. You can respond directly to the GoToWebinar um, invite as well. So I think that's probably about it. There aren't any questions coming in at the moment. So great job, Josh. And thank you
All right. Well,
everyone for
thanks
it.
everybody for sticking around and listening.
Yep. Thanks everyone for attending.